So we're going to first look at a few pages in the textbook. It says right here 11, 12, and 13. This is with water. So I've got that right here. It said 11, but I'm going to start on page 10. It's always a good idea for you to follow along with your textbook. Yeah, you hit the little like speaking thing with the textbook, so that's kind of cool that the textbook can talk to you. But don't be out of habit of actually putting your eyes into the textbook. I think it gives you a leap forward into critical thinking. There are several layers of learning. The bottom level is knowing these words, vocabulary. So you always want to have a foundation of knowing the words. So could you tell the difference between cohesion and adhesion with water? And so that is what you have to make sure you understand. Over here on the left-hand side of the textbook, it has the flashcards. Know the key terms. Don't let any of these trip you up. If you walk into a quiz not knowing the vocabulary, you're guessing. Statistically, multiple choice, and even true and false is not going to be your friend. You cannot guess your way to a good grade in any subject. Even if you went C's all the way down, maybe you'll get 25%. So you really need to study the vocabulary, and it's always bold in the textbook. The title to this section is called Hydrogen Bonds Make Liquid Water Cohesive. Well, there's a lot going on in that title. You'd have to know what hydrogen bonds are, and you'd have to know what the word cohesion stands for. So let's talk about water. I'm going to maybe even go back to another page where it had the molecule of water. Right here. This is section, what, 8? Yeah, 8. Hydrogen bonds. You need to know this for the quiz. There are two types of bonds in this picture. One is labeled as covalent bonds, and then the other a hydrogen bond. Let's start with covalent bonds. You can see H2O there in the center, and then there are 4 other water molecules all the way around it. Each one of these water molecules is made up of 2 hydrogens like Mickey Mouse ears and 1 red oxygen. Covalent bonds are drawn in as a straight line, a solid line. That's where the electrons are being shared. Hydrogen and oxygen, they're both short of electrons. So one can't give up electrons to the other. They all need the electrons that they all have, so they can't give them away. But like a potluck picnic, they each bring something to the table, and they overlap their valence electrons. And when they do, they all appear to be full. So this is the strongest bond there is when electrons are shared. It also labeled water as a polar molecule. And this picture shows that the hydrogen side of water is slightly positive, because that's where hydrogen's proton is sticking out. Hydrogen only has 1 electron, so its lone electron is actually in that line closer to oxygen. And so if you approach hydrogen, you're going to bump into its proton sticking out there. So hydrogen is always the positive side of a molecule. And then oxygen has a lot of electrons hanging out there in its valence shell, so that makes oxygen side slightly negative. So as we've learned, water is like a magnet, and it sticks to itself. That's what cohesion is. The word cohesive means together. Now, modern day's football team, have you been to a game? How do they start when they walk out on the field? Do they run? Do they walk? Are they all individual in a line? Or are they holding hands? What do they do when they come on the field? What do they do? They come in as a group, and most of them are holding hands, right? So that sends a powerful message to the other team. Watch, most other teams don't do that. They come out single file, onesie, twosies, a few here, a few there. They don't look like a cohesive unit. But if you have everyone locking hands or elbows, that means good luck getting through us, man. We are tight. We're a cohesive team. So that's what the word cohesion means. Sticking to itself, like all football players, all water molecules. When you have a polar molecule, the positive side sticks to the negative side of a neighboring water molecule. But these are also magnetized, and they can stick to other things like that. So here is water sticking to another surface. That's adhesion. Isn't that like adhesive tape? You can tape something. You can tape two things that aren't the same together. That's adhesion. So make sure you keep those two words apart. That was right there on page 10. That we'll make our way back to it. So the word hydrogen bond means that hydrogen is involved. That's the positive side, and it's going to stick to a negative side. When it does, it's a weak bond that can form and break apart real easily. Expect there to be pictures on the quiz, so you would want to know the pictures that you have in the textbook. While I'm on page 9 right here, follow along. It's easy to get to the other pages. You can click the menu, and then you can just click on the page for 9. Or you can use the arrows on your iPad. You just swipe. Really easy. This is called a chemical formula. There's an arrow in the middle, and this reads like an English sentence. 2 hydrogen molecules plus 2 oxygen molecules yields 2 water molecules. And you heard me say the word yields when I got to the arrow. So on the left side of the arrow, they're called reactants. They react together. And on the right-hand side of the arrow, these are products, things that are made. This is called a chemical formula. You'll also notice that it's balanced. How many hydrogens are on the left side of, let's call it a teeter-totter. Right here is the fulcrum of the teeter-totter. Right now it's balanced. The same amount of atoms on the left side as the right side. So one isn't heavier than the other. How many hydrogens on the left? How many total? That number in the front means there's 2 molecules. In each molecule of hydrogen gas, how many hydrogens are there? 2. So there's 2 hydrogens in one molecule, and there's 2 molecules. That's 2 times 2. There's 4 hydrogens on the left. 2 water molecules, each containing 2. That's 2 times 2 on the right. There's 2 oxygens on the left and 2 oxygens on the right. Only God can create matter out of nothing. In a chemical reaction, the only thing that's happening is rearranging. Break all these apart like Lego pieces, and then you can make a new Lego creation in a different form over there. But it's the same number of Lego building blocks. So now we're back to page 10. And while I was away, I gave you the definition of cohesion. and Adhesion. We had the penny surface tension lab, and we learned that water can really stack up, because it sticks to itself, and you get a bulge right over the top of the penny before it would break its surface tension. Is surface tension caused by cohesion or adhesion? Yeah? Cohesion, right. So when you see this insect standing on water, he's bending the surface tension of the water sticking to itself. So we spent a little time talking about hydrogen bonds. Because water is polar and forms hydrogen bonds, it can do some crazy things. It moderates temperature. How does it moderate the temperature? Well, we're almost to November and December, January, February. How cold is it going to get here in California, near the ocean? We all know, not very cold, right? Unless you go up to Big Bear. Probably going to be in the 50s, 60s every day. And usually in the 70s. But if you go to Palm Springs, which isn't far from here, but away from the ocean, it gets hotter during the day and colder at night. So the closer you are to a large body of water like a big Great Lake or the ocean, it moderates temperature. How does it do it? Hydrogen bonding. Here's the surface of the water. Heat from the sun has to first break through the hydrogen bonds. So part of the heat energy has to go into just opening up the water so the heat can go down in. So that's one thing, and then it closes and it traps the heat in like a blanket. So now when the sun goes down, there's the heat trapped in the large body of water. And as you have waves that open up these bonds, the heat comes out, then this forms again another blanket. So that's how water is able to moderate temperature. It heats up slowly, and it gives its heat off slowly. And so it stops big swings of temperature like you would have on land, just a little bit inland. So this page also talks about the evaporative cooling. So now this athlete has sweated, and our body heat is coming out with the sweat. So now you have this on the surface of your body, and it is going to evaporate off and take the heat with it. So it's got some heat trapped inside of the area right here. So this is why water is in all of our machinery to cool it off. It's in our car radiator. It's going to cool off power plants like what you see at Huntington Beach. So if I could get you to stay focused and stay off your phones, right? And also to not get distracted by your internet, I think it's a direct correlation to how well you do on a quiz. So I asked you to stay with us. So you should be on this page with the textbook. And you could even highlight things, so you should know about evaporative cooling. We're almost done with the textbook. I'm going to see how well you know your stuff. Did you know that gases take up more space than liquids? and solids take up less space than liquids. So as you go from a gas to a liquid to a solid, it gets more dense and everything sinks. So liquids are more dense. They're going to be at the bottom of a mixture of gas. If you dropped solid ice in a glass of water, it should sink, right? Because solids should be more dense than the liquid. But you all know that that's not true. That if you put an ice cube in a glass of water, it doesn't go to the bottom. It's going to rise to the top. So why is it that water is one of the only solids that will be less dense than its liquid? And if you are unsure about an answer on the quiz, if you answer because it's a polar molecule and understand that, that's usually the answer. Water is so crazy cool because it's polar. It has a positive side and a negative side and it sticks to itself. So here's a really good picture. Solids are supposed to be more compact, so you would think that that's the solid, but this is liquid, and this is the solid. So what happens to the water molecules as the temperatures slow down? Everything goes slower in cold temperatures. This is boiling water right here when the molecules are going really fast, but as it cools off in the freezer, they go slower and slower and slower, and they're moving slower and slower. And what happens is there's space between them because they've had time to form the maximum number of hydrogen bonds with all their neighbors. And then it creates all this space. Now you melt this and it speeds up and they roll over each other and they get closer together. So make sure you understand that water is less dense as a solid. Huge thing for life because a lot of life is in water. What would happen to a lake or the ocean if it froze and the ice goes to the bottom first and forms up toward the top? Life going to survive? Most life is at the bottom of the lake or the ocean. They're crawling in the dirt. They're eating each other. They have their homes there. So if ice sank and froze them out initially, every winter it would kill off everything in the lake. So having it form at the top provides a insulation barrier. You know, the Eskimos, they build their igloos out of ice blocks, and then they can live inside of the ice walls, and it's nice and warm. So the fish and the animals, as long as there's food down there at the bottom of the ocean, bottom of the lake, they can feed during the cold winter. All right. This is salt, sodium, and chlorine, just like you see up here. How can you take a solid and put it in water and it disappears? Is it a magic act? Obviously not. How do things dissolve? You can see from the picture that it's divide and conquer, right? So now water is going to surround these ions. That's what salt is. It's a negative ion and a positive ion. So water surrounds it like an army. That's always a good strategy, right? In war, you divide and conquer. So it divides up the ions and then surrounds them so they can't get back together again. How do they surround it? The negative ion is surrounded by the positive side of water, the white hydrogen. The positive sodium is surrounded by the negative side of oxygen on the water. The only way to get these two back together again is to evaporate the water out, and then they can snap back together again. And then we had the pH scale, and you know it's from 0 to 14 with 7 in the middle, and the acids are less than 7, and the bases are greater than 7. Why are we talking about the pH scale in a biology class? The last page here in the textbook for this section. Well, it has, I might come back to this page. I think there's one more page on the pH in cells. These 2 pages here center on how water is necessary for life because it's the universal solvent. So many things are dissolved in it. And we're walking chemistry sets. Our pH balance has to be right. Our temperature has to be right in order for the chemicals to work. As I mentioned, hot temperatures make molecules go faster and react faster. pH balance has to be just right for them to react as well. So when they search for life on another planet, they're looking for what we expect, just like here on Earth. You have to have water, or there had to have been water in the past. So at the end of the textbook, there's a good review. Have you seen it? So now I'm on the end of the chapter, and it's got a review. So I think if you look this over, you'd be like, yeah, I get it. I understand. Yeah, yep. Okay, there's my playbook. Yep, got it. I know that. Yep. I'm done studying. That's not studying. So if you don't get out there and actually try the skill, then you don't know if you're game ready. This is your playbook. The coach handed it to you and said, study this. But he didn't just mean have it up here. You have to actually go through the motions. So I've created a few things for you to test whether or not you are game day ready. And let's go over here and open it up. Somebody during office hours said, what? There's 2 tests? Kind of looks like it over here in the coming up. Chapter 2, the Chemical Basis of Life Dynamic Study Module. 0 points. It's going to be on our study guide that I'm going to show you. I think if you do this dynamic study module, it's different for each one of you. That's why it's called dynamic, and it is a study tool. It's part of our textbook, and I'll always make it available to you. Sometimes it will be for points. They have done tests, and they know that if you work with the study module, your grade goes up statistically, like 1 grade ladder. So if you get C's on your test, just doing the dynamic study module, you should get a B. And it's a tool that I'm going to show you how to do that in a minute. But we're going to start with the study plan. This is a 20-point study guide. And I just made it into points so that you would practice it. If I said, here's your study guide, you don't have to turn it in for points, a bunch of people wouldn't do it. So I'm going to go over the study guide with you. There's like 10 questions. So as I mentioned, make sure that you know the key terms. I showed you in the textbook how you can make that into a game. You can mark the ones that are giving you a little more thought and you're having to spend a little more time on it. So then when you do your study terms, you could just open it up and do your favorites. Do the ones you've marked. Doing the dynamic study module. So did you do this? Yes or no? There's no right or wrong answer. So be honest. When you turn this in, did you do the study module? Did you review the key terms? You know, there's no points for it, but if you do these tools, it will help you a lot. Number 3, that review that I just showed you in the textbook. after that, there were some questions that you could answer, and the answer key is in the appendix of the book. But also, right over here, I'm at Canvas, and there's a study area right here. And the study area has practice questions and access to the textbook as well. So have you been over here? Have you seen it? There's a practice test. So you would go practice test 2, and there's like 10 questions. Gives you the answer. But don't try to memorize this, because when the quiz asks it in a different way, and you've only memorized it, and you don't even know the reason for the answer, then that's not the way to do a practice test. Make sure that you understand the reason behind it. So those tools are there for you. Make sure that you utilize it. Let's go back to the study plan. And now here are some topics that are directly on the test. And so let's go over this and fill it in as we go. This is you're on the field now. You're in the batter's box. I'm going to throw fastballs and curveballs at you. Let's see how well you can hit them. Do you know why there are rows and columns in the periodic table? What?
It's like this separate, but that's pretty self-explanatory. But isn't it study of like the type of family that they're in, like what kind of elements they have?
Yep, and the word family is what they use. I don't care if you know what the names are, like groups and families and periods. But why? What's happening at the atomic level for why we organized it this way, other than just one big straight long line of 118 elements? How reactive they are? Is that a row or a column? How reactive they are is actually a column. This is the one from the end of your textbook in the appendix, and we went over it. If I zoom in, or maybe you could zoom in, I did make this a smaller file, so it's a little fuzzy. But it says right here that the groups are the columns, and they even say groups. That means vertically, it's the number of electrons in their valence shell. So do you know what valence means? It means the outer limits of the atom. The furthest electrons from the nucleus, that's the valence shell. That's where chemistry takes place. As two atoms are coming together, they'll collide. They're going to bounce into their electron clouds first, their outer limits. That's where chemistry is. So the columns represent how many electrons are actually there in that orbit. The electron orbit, but we call them electron shells because it's not a two-dimensional orbit. It's really three-dimensional space. So that's what the column stands for. Did you write it down? Number 1.1. The columns represent how many electrons are in the valence shell. And like what Gunnar said, it's how reactive they are. If it's missing one electron, it's going to be reactive. If it's missing 2 electrons, it's going to react differently. Savannah, do you know why there are rows in the periodic table? How many what? How many atoms there are? Nope. It has to do with the electrons again. What is it about the electron? How many what? That's the group. Really, how full they are the columns. Remember over here, these are called the noble gases. They're noble because they're all full and they don't react. I like the video. It said they don't get along with the riffraff. Everything to the left-hand side of the far right, all of these have a problem with their electron shells by not being full. This column right here is missing 1 electron. This column right here is missing 2 electrons. This one's missing 3 electrons, 4 electrons, 5 electrons. This has 1 electron in its valence shell. This has 2 electrons in its valence shell. And this periodic table shows it. It's a little fuzzy and dim, but there it is. 1 electron, 2 electrons in its valence shell, 3 electrons, and this is all full. Back to what do the rows mean? How many circles do you see around the first row of the nucleus? 1, right? How many blue circles for electrons are in the second row? 2 electron orbits. How many orbits are there in the third row? 3. So you can see by the visual representation there that the rows are the orbits where the electrons are located. Did you write that down for number 2? There are 3 types of bonds between atoms. The main one is covalent bond, the second one ionic, and then the third one that we've already talked about with water, the hydrogen bonds. So in the space provided, explain what is happening in a covalent bond. And I gave you pictures of these. These are pictures from the textbook. If you're in a sport, if you're in tennis, they're going to say, all right, let me see your serve. I'm going to go over on the other side and serve the ball up to me. You wouldn't go, oh, I could do it. I would throw the ball up and then I would hit it with my racket and I would have to get in that square right there. So I'm good. I don't have to do that. But no, yeah, you do. I want to see you do it. So when you take a pen to the paper and you write it out, that's you being on the court and hitting the ball. So unless you actually get involved with demonstrating it, right now you're being your own study partner by doing the answers here. But if you were at office hour and sitting with a friend and you go, all right, tell me what a covalent bond is, and then you just say it. It's when 2 atoms get together and they're both short electrons in their valence shell and they just overlap their shells and voila, they're full. Sometimes my electron is going to be over with you. Sometimes their electron is going to be with me. We just share. It's just going to bounce back and forth between us. And when that happens, it creates a strong bond between them. So in all these examples with hydrogen, oxygen, methane, and water, they just overlap their electron clouds, and magically they all feel like nobility. They're all going to have their fill of electrons and they are going to be stable. So the word here that you should write down is sharing. They share electrons. We spent a lot of time talking about ionic bonds, and this is when 2 atoms get together and they're not both short. One is short of electrons and one has an extra that it doesn't want anymore. So the magic word for an ionic bond is transfer of electrons. So here you can see sodium giving up its lone electron in its valence shell to chlorine that is missing 1 electron in its valence shell. Now you have an imbalance of protons and electrons because aren't atoms neutral to begin with? So sodium has 11 protons and 11 electrons. When it loses this 11th one, now it has 1 more proton than electron. That's why it becomes positively charged. Chlorine, it has 17 protons and 17 electrons. It's neutral. But when it picks up sodium's electron, now it has 18 electrons and 17 protons. So it has a net charge of -1 from that extra electron. So now opposites attract, and they're electromagnetically attracted to each other. How would you describe hydrogen bonds? Hydrogen is always involved, and hydrogen is always going to be slightly positive hanging out there in the molecule because its electron being covalently bonded to its neighbor, it's going to be toward its neighbor. So as you approach hydrogen from a molecule, it's got its proton hanging out there. It feels positive on that side of the molecule. And so it's going to stick to something oppositely charged, like another water molecule. Individual atoms from the periodic table will combine with some other atoms, and that's called a compound. Compounds mean more than one atom bonded together, like water. It's 3 atoms, 2 hydrogens and 1 oxygen. So everything that is more than one atom is called a compound. When can we call it a molecule? These words are not interchangeable. So write this down for the answer for 4. A molecule is a covalently bonded compound. A molecule is when you have a covalent bond between atoms. Salt is not a molecule because it's ionically bonded. Water is a molecule because it's covalently bonded. So everything that is 2 or more atoms is always called a compound, but we have a special name for covalently bonded atoms, and that's a molecule. And 5 and 6 we've already talked about. So water is polar because the hydrogen side is slightly positive. Oxygen side is slightly negative. It's also called a dipole. 2 differences, positive and negative, on opposite sides. Hydrogen bonds are only between neighboring water molecules. I can trip up half the class just about every time by saying, where's the covalent bond in water? It's between hydrogens and oxygens. But where's the hydrogen bond? It's between neighbors. It's between the hydrogen of one water molecule and the oxygen of another neighbor. Cohesion, when an atom sticks, a molecule sticks to itself. Adhesion, when a polar molecule sticks to something else. Yeah, we talked about the football team being cohesive. Those are all football players, like all polar water molecules sticking together. What? Number 6? Cohesion is when like molecules stick to themselves. Adhesion is when they stick to something else. Polar molecules will stick to another surface. Think of adhesive tape, enabling you to stick something to something else. The word solution means that you are mixing something in water. Water is a universal solvent because it dissolves more things than anything else, because it's a polar molecule, and it can surround and conquer, divide and conquer. The parts of a solution are called solutes and solvents. And here's an easy way to remember it. Have you ever dropped a coin and it rolled and maybe went down into the gutter, like where you can't reach it, went down into the drain? All right, now you just figured out which one goes into the other. We'll call the drain a vent, like an event, like a heater vent on the floor. And have you ever heard of the word loot? An old slang term, like a Western day for money. So don't let the loot go down into the vent. So you could draw a little symbol for yourself. You could like have a vent, just like a grate. Then you can have a dollar sign, and then you could show an arrow going down into that. Don't let the loot go down into the vent. So this is the loot, and this is the vent. Now you know which one goes down into the other one, right? What is salt? Salt right here is the solute. It's the loot going down into the solvent, which is water. Just a memory trick. It works for me. If it's confusing for you, then erase it. And just make sure you keep them straight. Solutes are always the thing that gets dissolved, and solvent, like water. Think of water as the universal solvent. You know the parts of the atom. In the nucleus, you have positive protons and neutral, no charge neutrons. Orbiting the nucleus are the electrons in orbits. What is an isotope? It is a different number of neutrons than is expected. Right here, black is a neutron, but if it had 3 neutrons, then it would be an isotope. It could have 4 neutrons and be an isotope. And we talked about how some of these isotopes are radioactive. They break down, they're unstable, and they're giving off pieces of themselves. We did this earlier, right? Everything on the left-hand side of the arrow is the reactants. You could circle that word and then circle this. You could circle products and products right there. Conservation of matter means that only God can destroy matter or create matter. Otherwise, it's just a rearrangement of all the matter in a chemical reaction. The pH scale, 0 to 14, 7 water right there in the middle, neutral. Acids are going down towards 0, bases going up toward 14. What makes an acid? You can see from the picture in your textbook, H+. Here's water. H2O right there in the middle at 7, pH 7. When you have a lot more H's, then it becomes a small number. When you have a lot more OH minuses, then it becomes a base. That would be up to like 14. We're going to do a Socrative right now. Let's see how well you can answer 10 questions. This is just practice. The coach has asked you to go out for a pass and try to catch the throw from the quarterback. 458851 is the classroom. Go to Socrative covalentbonds.com, or maybe you have the app. I'll paste this, so head on over to socrative.com. Is this the app? How do you spell it? S-O-C, I have it in red. Yep.
And then
So you're going to just do login and student login, and then it's going to ask for the room number 458851. It's up in blue on the top of the board. Yes, I got to spell it right. See up on the board. Oh, you just misspelled it. So it's up on the board in red. 458851. Yep. So log in on the top. Student login, and then 458851.